Welcome back. We'll continue our discussion on methods of finding residues of function f of z. So in the previous case, we discussed about how to find residue of a function f of z at simple pole z equals to a. So in this session, let's see how we calculate the residue of a function f of z at a pole z equals to a of order n. So the statement is if f of z has a pole of order n at the point z equals to a, then the residue at this pole is given by 1 over n minus 1 factorial multiplied by the derivative n minus 1 derivative of z minus a power n times f of z so that's the formula. And then you remember to put the value z equals to a. So let's see how we do that. Now, proof of this. So if z equals to a is a pole of order n, of a function f of z, then by Lorentz theorem or Lorentz series, we have f of z is given by a naught plus a1 z minus a plus a2 z minus a squared plus other terms plus b1 over z minus a plus b2 z minus a squared plus bn z minus a power n. So that's by definition using Lorentz series. Now multiplying so let's call this one equation 1 by z minus a power n, we get, so I'm multiplying every term by z minus a power n, so we'll have z minus a power n times f of z will be given by a naught z minus a power n plus a1 z minus a power n plus 1 plus a2 z minus a power n plus 2, and then plus b1 z minus a power n minus 1 plus b2 z minus a power n minus 2 plus b3 z minus a power n minus 3 plus the last term will be bn. So let's call this one question 2. And then differentiating both sides. Of 2 with respect to z n minus 1 times, and putting z equals to a, we get, by differentiating this second equation with respect to z, z minus n minus 1 times, and replacing with the z by a. So we'll have the n minus 1 derivative of z minus a power n f of z and then we put z equals to a, will give us the first, this will give us n minus 1 factorial times b1. So which means making b1 the subject, we'll have 1 over n minus 1 factorial, and then n minus 1 derivative of the function z minus a power n times f of z at z equals to a. So hence, residue, remember residue is the same as b1, residue of the function at a is given by 1 over n minus 1 factorial, and then multiply by n minus 1 to the derivative z minus a power n times f of z, and then you evaluate this value at z equals to a. Now to clearly see how the n minus 1 factorial comes in, you can try to do the first derivative and then see the number, second derivative, third derivative up to the nth minus 1. And then you get the pattern to see that all of them will be of the form n minus 1 factorial times b1. So this is what we were to prove as the formula for calculating the residue of the function f of z at a pole of order n. So this is the solution. Thank you.